Here we go, Mr. Trutna. Right there, Math 2, Clovis High School. Remember, as you watch this video, smash that like button for me. We're going over the Unit 1 review worksheet. We're not going to do every single problem. Some of the problems you were not asked to do. So we're just going to go over the assigned problems, starting with number 2. Alright, so what we do in number 2 is we're finding the value of x. That's going to make the lines parallel. So what you do is you assume that the lines are going to be parallel to each other. You pretend that they are, even though it's not necessarily correct in this case. And then you're going to compare that angle right there, which is marked as 150 degrees. And then you're going to compare it to this angle right here, which is marked as x plus 8. X divided by 8 plus 60. Okay? Well, what type of angle, and then you're saying to yourself, what type of angle relationships are those two angles? Well, those two angles are alternate exterior angles. And if you recall, alternate exterior angles, if the lines are parallel, they're going to be equal to each other. So, since they're equal to each other, you're going to take the expression for this angle, x divided by 8 plus 60, and you're going to make it equal to the other angle, which is 150 degrees, and then we want to find the value of x. So we're going to solve this equation. We're going to subtract 60 from both sides. That would cancel out those 60s, and then we would get a new equation of x divided by 8 is equal to 90. And then what we would do is we would actually multiply both sides of the equation by 8. And the reason why we're multiplying is because I have to do the opposite math operation. I'm solving for x, so I have to isolate the x. I'm dividing by x, so the opposite is multiplying by x. Those 8's would cancel out, and I get an answer of x is equal to 720. There's your answer to number 2. X is equal to 720. Okay, the next problem was number 4. We're using the same concept we did in number 2, except for we're going to have a different angle relationship. So we have this angle that is represented by 2.7x plus 96.52, and it's that angle right there, which I just outlined in green. And then we have the other angle, which is represented by the expression 6.5x, which is that angle right there, which I just outlined in blue. If you notice, both of those angles are on the interior of the lines that we are assuming we want them to be parallel. So let's assume they're parallel. Well, those are alternate interior angles. What's true about alternate interior angles? They are congruent, which means they are equal to each other. So I'm going to take this angle's expression, 6.5x, and I'm going to make it equal to that angle's expression, 2.7x plus 96.52, and then I'm going to solve this equation. Okay, so my first move is I have x's on both sides of the equation, so I'm going to eliminate the smaller side's x's. So I'm going to take away 2.7x from both sides of the equation. Now when I do that, those 2.7x's would cancel out, and I would get, let's see, that would be 3.8x was now equal to positive 96.52. And then to solve for x, our variable, I would divide both sides by 3.8. Okay, and here's where a calculator would definitely come in handy, and it's definitely okay to use calculators as you're doing these problems. So working this out on my calculator, I would go 96.52, and I'm dividing it by 3.8, so my answer is 25.4. Alright, so x is equal to 25.4 for number 4. Okay. Next problem that was assigned to you was number 6. Now when we get to numbers 5 through 13, we're simplifying the radical. Okay, so how do you simplify the radical? Well, you take the radicand, which is the value inside the radical symbol, and we're going to make a factor tree out of it. That's always our first step. Okay, so what are two numbers that multiply to make 80? I'm going to go with 8 times 10. And then I'm going to keep factoring until I end up with prime numbers. 8 can be factored into 4 and 2. You can factor 4 into 2 and 2. but you cannot factor 2 any further because those are prime, so I'm going to circle. So every time I run across a number that is prime, which means I can't factor it anymore, I'm going to circle it. Now I'm going to go up here to 10. 10 could be factored into 5 and 2. And 5 can't be factored any further, so I'm going to circle it because it's prime. 2 can't be factored any further. So that's always my first step. Then my next step is I'm going to rewrite this radical, but I'm going to rewrite it, instead of putting 80, I'm going to make it as a product of all my prime factors. 5 times 2 times 2 times 2 times 2. Now remember, you should multiply these numbers back out to make sure they still equal that 80. And don't forget about that negative sign. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So my factors are correct. Okay, so now what I'm going to do is I'm going to factor out any identical pairs of numbers. And every time I get an identical pair of numbers, I'm going to cross them out, and I'm going to move that number out to the front of the radical sign, a 2. Why is that? Why do I put a 2 there? Well, 2 times 2 is 4. The square root of 4 is 2. Notice I have another pair of identical numbers, so I'm going to cross them out from the radicand, and I'm also going to move that out to the front, which we call the coefficient. So I end up with 2 times 2. If you end up with multiple values outside from factoring them out, or from square rooting them out, you multiply them together. So I have a 2 and a 2, that's 4, but I have a negative. So I'm going to have a negative 4, and then I'm going to have the square root sign, and then I have a 5 left over. There's what number 6 simplifies to. Negative 4 square root 5. Or you could say it as negative 4 radical 5. Number 7, going to do the same idea. So the first thing I'm going to do is I'm going to factor the radicand, which is the 52. Find 2 numbers that multiply together to make 52. All right, well, 26 and 2 make 52. And I'm just going to keep factoring. 26 can be factored into 13 times 2. And then you cannot factor 13 anymore, so I'm going to circle it because it's prime. You can't factor these 2's because they're also prime. Okay, that's your first step. Your next step is you're going to rewrite this problem, but instead of 52, you're going to write it as a product of your prime values. 13 times 2 times 2. And don't forget that we started with a 7 out in front of the radical sign, so we got to have a 7 there. Okay, so now what I'm going to do is I'm going to circle any identical pairs of numbers, cross them out, and and square root them, so the square root of 4 becomes 2, so I'm going to move a 2 out here. Alright, and that's it. I have no more identical numbers. So now my answer is I'm going to go 7 times 2, that gives me 14, put the radical or the square root symbol, and then I have 13 as the radicand. So number 7 is 14 radical 13. Number 13, the next one we're doing here. So in number 13 we have the quantity 3 square root of 6 to the second power. So what we do is we are going to rewrite the base, which is everything below the exponent, which is 3 square root of 6, and this means we're going to multiply it by itself. Okay, that's what, remember, second power means. Multiply the base by itself. So now I'm going to multiply this out. So I'm going to take the coefficient number and multiply it by the coefficient number. 3 times 3 gives me 9. Then I'm going to put the radical symbol, and then I'm going to multiply the radicands times each other. The numbers on the inside. 6 times 6 gives me 36. Okay, well, I'm not done yet because you should recognize 36 as a perfect square root. So the square root of 36 is 6. Okay, it's just 6. Don't write square root 6. It's just 6 times the 9 that's already there. Therefore, number 13 simplifies to 54. Okay, so there's my answer to number 13. Number 7, number 6. All right, turning the page over, number 17 was your next assigned problem. And in number 17, wait till you can see it, there we go. Number 17 is asking what angle is adjacent to angle FBD. All right, so let's find angle FBD first. That means you start at F, follow it to B, and then go all the way to D. So that is the angle that we're talking about right there. So we're asking what angle is adjacent to that. Now remember, the word adjacent means I have to find a second angle that has the exact same vertex as angle FBD, and then it has to share a side, it has to have a common side. This angle would work right here. Notice that blue angle and the green angle both have the same vertex, which is B, and they share this ray right here, this side. Okay, so that would be angle EBF. So that's a possible answer for number 17. Angle EBF. Now remember, if you wanted to, you could reverse the order of the letters, and you could have called it angle FBE. That would be perfectly okay as well. All right, number 18. Number 18, we're saying what angle is formed by the combined angles of angle 1 and angle 2. All right. Sorry, I had to walk away and grab another marker. I'm going to use a highlighter for this one. So, angle 1 is this highlighted part right here. But I'm going to combine angle 1 and angle 2. So you can see if I started here at A, that gives me to the vertex, but I'm going to go to angle 2's vertex to combine. So that would be angle ABF. So number 18 would be angle ABF. Okay, and once again, if you wanted to reverse the order and called it angle FBA, that would be perfectly acceptable as well. Number 23. Number 23, we are using this diagram right here, and then it wants us to name two pairs of vertical angles. All right, so angle 1 and angle 2 are vertical. That would be 1, and then there's another pair here, and that could be, and actually there's more than one. You could say angle 5 and angle 6. Okay, that would work. All right, there's more. You could have put 4 and 7. So you could have said angle 4 and angle 7, or if you also could have said angle 8 and angle 9. So in this particular problem, it said name two pairs. There were actually 4 pairs of vertical angles. Okay, that was number 23. Number 27. So the instructions say for number 27, in a triangle, angle 1 and angle 2 and angle 3 are interior angles. So notice angle 1, angle 2, angle 3, they're on the inside of the triangle. And angle 4 is an exterior angle with remote interior angles 2 and 3, angle 2 and angle 3. We're going to find the missing angle measures, show all work. Okay, so this one we're going to show all work. So number 27, we know that angle 2 is 60. And I'll go ahead and I'll mark that. It's going to get a little messy because I'll do more problems. Angle 3 is 80. Okay, so then we have to find angle 1 and angle 4. Those are my missing angles. Okay, well, notice angle 1, if I add it to the 60-degree angle, which is angle 2, and if I add it to the 80-degree angle, which is angle 3, the 3 interior angles of a triangle always have to add up to 180 degrees. If you recall, we called that the triangle sum theorem. Some people call it the triangle angle sum theorem. So then I'm going to solve this for angle 1. So that would give me angle 1 plus 140. 60 plus 80 is 140. That's equal to 180. I'm just dropping the degree sign. I'll put it back in at the end. I'm going to subtract 140 from both sides. Angle 1 is equal to 40 degrees. So there is my first one. So you can see over here in my answer column, the measure of angle 1 is equal to 40 degrees. Okay, so I'm now going to mark angle 1 as 40 degrees. Now I need to find the measure of angle 4. Well, angle 1 plus angle 4, they make a linear pair. That means those two angles are supplementary. That means when we add them up, they have to equal 180 degrees. Okay, I know angle 1 is 40, so 40 plus angle 4 would be 180, so I'm going to subtract 40 from both sides.